Right, good morning everybody. Hopefully you can hear me. And welcome to this webinar on how to build a low energy home without the premium cost. I'm David Reid. I'm one of the engineers here at Mesh Energy. So this morning we're going to look a little bit at the sort of design process that we go through with a new low energy home. We're going to do quite a long case study looking at a project that I actually worked on called Applehurst, and we're going to look and contrast some of the differences between how we do a project here at Mesh and how a more traditional project might be run with a slightly more linear style of project management. One of the things that I sort of will caution you about is that I'm going to try my very best not to make this sound salesy, and just literally concentrate on this as in quite a sort of fair and balanced way. But this is probably, of all the webinars, probably the one that has the danger of sounding salesy if I'm not careful. So please forgive me in advance if I do start sounding a little bit like a salesman a couple of times during this. So just for those of you who've maybe never joined one of our webinars before, I just want to give you a little bit of a background about who Mesh Energy are. So our mission statement is to instill confidence and pride in low energy projects through intelligent design. And the two sort of real main bits to that are the confidence and pride bit, which is about obviously people want to be proud of the buildings they live in and the buildings they work in. Obviously the low energy part is quite important and is in our company name, and probably the most important part of that is through intelligent design, and it's the intelligent design piece that this presentation really concentrates on. And a little bit more about it. We're independent, so we're not tied to any particular manufacturers. We're not tied to any particular technologies, and we try and simplify things as much as possible, and partner with architects so that we work in a way that everybody can see what's going on. So what we'll cover in this presentation is a little bit about how the design process is evolving over time, some of the key services that Mesh offer, and how those sort of same things might have been traditionally delivered. Then we're going to walk through a case study and look at some of the key stages up against the REBA stages, and the costs associated with that. Is quite an open book style of presentation. So we're actually going to, in the case study, we will share what some of these things actually did cost us in real life. And then with the case study, we'll look at the sort of cost benefit overview. So we'll contrast how the sort of the new style compares with the old in terms of actual consultancy fees. And then we'll finish off with some sort of key takeaways and a little summary about what hopefully you've learned from this presentation. So the evolving design process really looks at how we're moving away from this quite low sort of linear style of design towards a much more collaborative approach. Doug mentions an awful lot of this in his book, The Right First Time, and we are really working along the sort of guidelines that are contained in that book. There's a link right at the end of this presentation, and you will receive slides for this presentation. So everybody who's registered onto the webinar will receive a copy of the slides. And you can download a free copy of the book and have a read at your leisure. But basically what we're trying to do is we're trying to de-risk the way that low energy design is done, And that can be through this more collaborative way of working, and also by moving a lot more of the design to the upfront part of the project and away from the sort of back end of the project where it might more traditionally have been done. This should reduce wastage and reduce over-design in things, and that's particularly important when you start looking at some of the key renewable technologies, things like ground source heat pumps, air source heat pumps, those sort of things. They can become quite expensive if you over-design them. And it's also about targeting things in the right areas, and we'll look at that in a little bit more detail. So just to sort of summarize, it's rather than doing things in a linear way where a building is sort of designed, then the M&E services are put in, and then it's installed, and then it's commissioned. It's looking to try and parallel a lot more of that design work up front, so that each specialist area is feeding the other, and so we come up with a solution that sort of encompasses everybody's expertise. So more thinking up front, more collaboration, and by getting that slightly longer lead time, maybe in the design phase, we get a better developed design, which then means that there's less decisions to be made on site, and then that creates less wastage and less over-design in the final outcome. And obviously, the more settled something is, then the less risk. So we're taking out design risk as well, and also people are designing the piece that they're expert in. So again, it's that reduces the design risk. Obviously, with all that, there is an increasing amount of modelling being done, and it's that modelling that you really couldn't do by hand, and you are reliant on software to do that. And we'll look at some of those things. So a little bit about the journey. So our sort of first stage of this journey is getting the pre-planning and the conceptual design right, and that's things like, which way is the building going to be orientated, what fundamentally are going to be the principles of construction, what area, where are we going to put the building on the site. It's simple things, but actually if you make a mistake at that stage, it can be pretty costly to undo and take quite a lot of time. And just some very simple modelling can answer those questions pretty quickly. Then further down the line, you're then looking at the detailed design. So that's making sure that all those little details, those junctions, everything else is all correct, and then integrating the M&E services into the building, making sure that's all done in a practical way, that sufficient space is allowed for plants and all those kind of things. And then going out to tender, making sure that keeping the costs under control, and then finally the building completion. So as the building actually is being constructed, making sure that everything is being done, and then that the handover is done well, and finally the monitoring. Although that's not particularly common at this stage, that's how we're how the sort of the ideal process would be followed. And the goal obviously is that we develop and build a successful low energy building, and that's low energy both in terms of the embedded carbon, so that's the carbon that's sort of in the building and always going to be there, and also the operational carbon, so that's the sort of day-to-day users and the things that people think about, the amount of fuel you're actually putting into the building, the amount of CO2 the building's giving out on a day-to-day basis. So let's have a look at some of the old versus new ways of doing things. So the next slide shows the REBA stages. I'm sure you're all pretty familiar with these, as most of you are architects, or at least working in that sort of environment. So from the initial client brief, we're seeing that the concept design is being done, and so this is sort of REBA stages 1, 2, and 3. Then as it works through into the more detailed design and specification, we're looking at REBA stage 4. Finally, we're looking at the build and handover in stages 5 and 6. And then, although we don't touch on it that often, something we're encouraging people to get more involved in is stage 7 as well, the in-use. So that sort of then feeds back into future projects. And there's always things you can learn from a project and feed those into future ones. So traditionally, this might be at stage 1, you might be just doing some basic SBEM and SAP or SAP calcs to make sure that the design is going to meet the requirements of building control. Then you might do a specification design at stage 4, a full M&E design package also at stage 4, then maybe a little bit of tender review at stage 5, and then obviously the overseeing the build. So where does MESH feed into that? Well, first of all, at this renewable spec and design stage, what are we going to actually specify? Why are we going to specify them? Is it because we've spoken to a great salesman from a particular installer and he's convinced us that a particular technology is the best way of going? Well, that's probably not the best way of doing it. Then also this tender review stage, a lot of people overlook that, but you know, and they just look at the prices and say, well, you know, the cheapest price is the cheapest price, and we'll go with that. But actually, there's more to a tender review than that. Does what the person has actually said he's going to provide actually meet the specification in full? Does it actually give all the benefits that the customer really wanted? Or have they sort of artificially lowered the price by maybe leaving out a few little key features that actually make a bit of a difference? So here's how MESH might look at this. So at stage 1, as well as doing the SAP calculation, we'd also look in a lot more detail at this thermal model and the ventilation modelling. So that's about getting the form of the building right. It's about selection of materials. It's about modelling how airflow might go through the building. So it's about, and all that then feeds into this specification further down the line. It's really important that you look at the building holistically and not as a building and a heating system, because the heating system serves the building, so and all the M&E services. So if you can make the building more thermally efficient and not overheat, then that might have implications further down the line in terms of selection of the M&E services to go in. Building fabric optimization is so important, especially in retrofit, and we'll have a look at this in there's a little sort of sub case study coming up where we'll see the effect of this building fabric optimization, and then also a feasibility study. So that could look at a number of different technologies and see which one suits the building the best. At this stage, sort of between stages 4 and 5, this installer recommendation phase, clearly there are thousands of different installers out there who are offering their services, and actually finding the best installers, especially some of the key technologies, is really important, and that can be the difference between a well-designed project being well implemented and a well-designed project falling flat on its face. And a poor choice of installer can cost literally thousands and thousands of pounds. Then during the build phase, MESH also offers build phase consulting package. Again, I'm not going to go too much into that, but it's really overseeing what the installers are doing, ensuring that the design intent that's been designed in all the way through from stage 1 all the way through to stage 4 is actually being implemented on site, and then finally making sure that all the subsidies that are available have actually been applied for correctly, and that the person who's actually going to use the building benefits as much as possible from those subsidies. And finally, the stage 7, the energy monitoring. And as I said, that kind of completes the circle back for future projects. But it's important that energy monitoring is done as often as possible, because apart from anything else, it helps everybody in the project learn, but it also may highlight something that maybe wasn't done quite right, that's difficult to spot on the surface. That can be something as simple as flow temperatures being incorrectly set or something like that, which causes more energy to be used than was forecast. So the case study we're going to look at is a building called Applehurst. We will see that it's quite a grand new build house, and it's concrete and steel construction, timber clad. It's got fairly extensive double glazing throughout, and it's got MVHR throughout, and it's also heated by an air source heat pump. It's actually a project that I did the tender spec and design for the for Strom, who are the architects. It's going to be a fantastic family home. What you can't quite see from this photo is that on the sort of left hand, or from this rendering, is that the ground sort of drops away to the left of this photo, and there's actually a carport underneath that bedroom wing, which you can't sort of quite see from this render. And then obviously they've got the main bedroom sort of section on the top here, and then all the living area on that sort of ground stroke mid floor. So everything that I'm going to mention here does scale down to smaller builds. This is obviously quite a high spec building. We're talking about a £1.2 million build at sort of around £2,500 per square metre. But this does scale down, so don't panic that this only works if you're building a really high-end house. It's just that because Strom decided that they wanted to go for the whole package, it makes quite a neat case study. Okay, so let's have a look at the first part. So this is actually the thermal model we built of Applehurst, and you can see that we use a system called IES, but the principles are the same for lots of different sets of software. But basically, what you're doing is you're building a 3D model of the building, which is correctly orientated in the landscape. You can add in things like overshading and trees and other buildings and all those kind of things. So that allows you, once the model's built, to do lots of very, very clever things with this model quite quickly. So yes, there is a cost for building this model, but once it's built, you can run scenarios on it quite quickly. So for example, you can look at, well, if I change that window from a non-opening window to an opening window, how does that affect the ventilation? Does that mean that, how does that affect overheating, for example, in the summer? I'm sure we're all quite conscious of overheating after the couple of weeks we had, what was it, the week before last, where it was unbearably hot for quite long periods of time. Managing that heat is going to become increasingly important. So you'll see here that we've got this green overhang over the sort of balcony on the bedroom wing. That balcony also then helps provide overshading for the big windows on the downstairs living areas, which again helps mitigate any overheating down there. Even that glass balustrade along the front provides some shading to the windows behind it, and again that helps mitigate overheating. So you can see there's lots of interesting ways that you can use the model to see what's going on. You can also do things like daylight analysis. You can add solar panels onto the model, but this really is the backbone of early stage design, and it allows us to work through designs really quite quickly. And that avoids the risk that when we start doing an M&E design further down sort of further into the project, by doing this in parallel at this stage of getting the thermal model right, getting some of the M&E services spec'd quite early on in terms of their general layout, it means that we're unlikely to have to go back to the planning department again and say, actually, you know what, we need to reapply for this part or this part of planning because we've had to make a change that we weren't expecting. So getting this done up front really can save quite a lot of time and money further down the line. And just as a sort of rough ballpark, this initial pre-planning analysis for Applehurst, which, as I say, was a 450 square metre house, quite a large house, came in at about £1,000, so plus VAT. So it's not an insignificant amount of money, but if you look at how much it has the potential to save further down the line, I think it represents good value. So I said earlier that we were going to talk a little bit about this building fabric optimization, and this graph on the right hand side of the screen is actually from a retrofit project which we looked at. And what building fabric optimization allows you to do is it allows us to benchmark the construction of a building and look at each of the thermal elements individually. So that could be different wall constructions, different roof constructions, windows, doors, and actually really analyze out where the costs are going to be, the running costs are going to come from in that building. So it's quite a clever piece of analysis, because it could be that you look at a roof and you say, well, the roof is by far the largest area on this house, but how much does that actually contribute to the running cost? It could be that if it's got quite a good U value already, although it's the largest single area, it doesn't actually contribute that much to the overall running cost. And in this case, as you can see, the external walls, the existing external walls, which are this big green block, was actually the piece that was costing the most amount of money in terms of the amount of carbon and the amount of energy that was being absorbed or going through those walls and out into the world. So by making a relatively small thermal upgrade to those existing walls, we managed to massively reduce the running cost for that house. And that allowed the homeowner to make an informed decision about where to spend their money on upgrading the building. I'm sure you'll have heard us bang on again and again about the energy hierarchy and the fabric first. Well, this is a great example of how fabric first really could help reduce the cost of a project, because for relatively low cost, we were able to really knock some significant savings, or knock off some significant costs of running for the building. And this type of fabric optimization for a building size of Applehurst, that was, again, it was around the sort of £800–900 mark, and obviously for smaller buildings would be less than that. So once we've got the basic outline of the building set up, we know which way it's going to be orientated, we've got the basic layout of the building pretty much sussed, we then really need to sort of drill down into how to develop that design into a tender specification that we can get people to actually price against. So the first stage of that quite often would be a feasibility study, because there are a whole multitude of different low carbon technologies available, and some are going to suit different homes better than others. But often it's not obvious which the best solution is for a particular building. There are some pretty good rules of thumb you can use, and you can probably get fairly close to the answer. But actually number crunching those things can really help. And often people have a fixed capital budget, so it might be that whilst they'd love to go for a ground source heat pump, they simply can't afford to, and actually they need to look at an alternative. So then it might be, well, I've got mains gas on site. How does that compare in terms of my running cost to putting an air source heat pump in? If I put an air source heat pump in and I'm intending to live in this house for 20 years, how much more is that? How much more or less is that going to cost me over that 20-year period than, say, putting a gas boiler in and then changing that gas boiler to an air source heat pump further down the line? How does biomass fit into this? I mean, on Applehurst, we looked at the full gamut of technologies with the exception of biomass. And actually, because of the site, because of the geography of the geology of the area, because of the fact that it was actually a very thermally efficient building, we actually ended up specifying an air source heat pump, which most of the rules of thumb would say a building of that size might be better off on ground source. But when you actually crunch the numbers, an air source heat pump ended up offering the best value for money. We also looked at how solar PV could feed into that equation, and also how batteries and also MVHR could feed in. And MVHR obviously plays off against the heating load, so there was lots of things that we could play with in that scenario, in terms of changing the efficiency of the MVHR system, specifying a more or less expensive MVHR system against natural ventilation, and seeing how that then affected the overall capital cost and the running cost of the project. We then also quantified the government subsidies, as we would do on any project. So things like the renewable heat incentive, which is obviously the government's sort of flagship green scheme still at the moment, for new build, where we were able to look at how much money we could get back through the RHI, and offset some of that additional capital cost that's associated with green projects at the moment. So the feasibility study and energy strategy, and the recommendations that came out of that for Applehurst, and again, sort of reiterates a pretty large house, that came in at £1,645 plus VAT. So you can see that the costs are adding up a little bit at the moment. We're up to about £3,500, I guess, in total so far that we've spent, and we haven't got a tender spec yet. So we've spent a little amount of money, but we've spent it in the right places. We've got a well-insulated building, which we know is going to be thermally efficient. We've got the right ventilation strategy. We've got the right mix of technologies now. And crucially, we've allowed the architect and the client to make some informed decisions based on actual numbers rather than rules of thumb or guesswork. So that's where the big decision comes, is okay, we've made all these recommendations. What are we going to do with those recommendations? Are we going to accept them in full, or are we going to do something different? And sometimes we'll come up with a feasibility study and we'll say, we think the best value is to do X, but actually the client, for whatever reason, and sometimes it's the capital cost of something, or it sometimes is well, actually I just quite like the idea of this technology, or it could be another thing. It says, okay, actually I take that, but actually I'm going to do something slightly different. So we then get a proper brief for what we're going to specify, and then we do a detailed M&E specification. So this is where we really get into the nuts and bolts of making sure that everything is nailed down in terms of exactly which technology we're going to specify, exactly where we're going to put everything, things like duct runs, cable runs, electricity requirements. Everything else is all thrashed out at this stage. This M&E package doesn't require a separate M&E consultant. This goes through MESH typically as the M&E consultant. But what we try and do with what we deliver from this is we don't go through everything that's already been said in the feasibility study, and we don't go the other way where you see in some commercial style M&E specifications where they're massively long and actually give you a huge amount of detail you don't need. What we try and do is we try and really distill down into what the key things that somebody who is tendering for this job needs to know. And that is, what's the technology going to be? What am I actually specifying? Where are the pipes going to go? Where are the cables going to go? Where are the ducts going to go? How is all this going to interface? What am I going to be responsible for? That's really that's really the things that he wants to know. I mean, yes, obviously we mentioned British standards, that things need to be installed to, and all the rest of it, and all the other things that go alongside that. But ultimately, what we're trying to do is we're trying to enable a good installer to give an accurate price. This is probably the most expensive part of the most expensive single item on this sort of shopping list of things. And in the case of Applehurst, it was about £10,500 plus VAT for this tender spec document. And whilst I say we try not to make it overly lengthy, I think because of the number of different technologies and the number of different interfaces there were for this, it actually came out as being about a 40-page document. But if you've ever seen one of our specifications, hope you'll agree that they're relatively readable compared to some of the stuff that comes out from traditional M&E consultants. So once that tender specification document has been written, clearly the next thing to do is we need to make sure that we've got a reliable and good quality installer on board. And this is where the installer recommendation and tender review part comes in. And Mesh have been in this game for a little while. Obviously, Doug and myself and Andy, who do work on the M&E side, have obviously been involved in the industry for some time. And we've got a pretty good idea of who the good installers are in a particular area. So we'd recommend our installers based on our own experience of working with them in the past, their track record, their location, because we know that a poor installer choice can really break a project, and it could undo all the good work we've done up to this point. So although this is a relatively low cost part of the project, we think it is absolutely crucial to getting the end result right. And finally, when all the tenders come back, what we do is we would then feed that into a sort of matrix to make sure that everything that is that we've asked for people to do has been allowed for within their tender document, so that we know that we're comparing apples with apples on the final sort of comparison. And then obviously it's up to the client which of those tenders they then choose, but we try and give them again the information so they can make an informed decision. And in the case of Applehurst, that was about a £1,500 cost plus VAT. So obviously I've got to move away from the Applehurst example now because this is really where the Applehurst project's got to. So we're going to look at so these are sort of more generic things rather than Applehurst particularly, but the costs still are still what we've quoted for the Applehurst project going forward. But what we tend to do is we would then typically get involved with the project in terms of making sure that there's sort of an appropriate level of site supervision. Now that will depend an awful lot on the site team that's involved, how competent that team are, how experienced they are in low energy projects. We know there are some fantastic project managers out there who need almost no hand holding at all, no input from Mesh. We can send the tender specification out, we get the returns back, we make our we prepare that comparison matrix, and then we can pretty much hand it over to the project manager. Obviously, some people like to self-build a lot more and will need a lot more hand holding. So this is of all the prices probably the one that's a bit more of a how long is a piece of string one, but typically we might do three visits, to site. One at the kickoff to make sure that everybody understands exactly what they're doing, knows exactly where they're going. One in the middle of installation, so we can see that, that everything seems to be going according to plan. Sort out any little interfacing issues that may have come up, and then finally one at commissioning, so we can oversee commissioning and see that design intent has still been sort of carried through all the way to the end. So that's what we say, often 2 to 4 meetings. Typically 3 would be the most common for that. But some more complex sites, they want us to attend site more often, and that's absolutely fine, but others will be significantly less. In the case of Applehurst, it's a couple of hours from the office, and we've allowed for 3 meetings, so that's come in at about £1,600 plus VAT for that, and obviously phone assistance, is included within that. And so then the subsidy allowance. So we would help with the applications for things like the RHI, making sure that all the relevant boxes have been ticked, all the relevant paperwork's completed, MCS has all been done correctly, and that all the required energy monitoring has been put into place. In this case, for Applehurst, that came in at just under £500 plus VAT. So you can see it's adding up slowly, but I think you can see there's a value to each of these stages, and it's a much more of a project-long support rather than a sort of a one-off piece of input. So these are the final costs. So thermal modelling was 995 plus VAT. Building fabric optimization to sort of refine that thermal model and get the building absolutely spot on was 825. Then we did the feasibility study to make sure that we were absolutely clear about what the best combination of products was. Then the M&E Design and Specification, so detailing everything, all the findings of the feasibility out into a real specification that somebody could price against. Then finally the tender review and installer recommendations, and then finally the build support and the subsidy assistance. And that came to a grand total of about £17,500 plus VAT, which represents 1.9% of the build cost for Applehurst. So you can see it's just under that 2% threshold that we usually sort of say is about the amount that we reckon. So how does that compare to a more traditional way of going? Bearing in mind, obviously, that there's an enormous amount less risk involved in this. Well, we know that for a typical M&E consultancy thing, we'd be expecting a cost of between 1.25 and 1.5% of the build cost. So it's a little bit more expensive, but let's see how that breaks down. So first of all, we've got the SAP calculations up front. Well, that's going to be the same for both. And then there's a full M&E design and specification. And then obviously we've sort of put some dotted lines in at the end here because this is typically it's around 1.5%, but it can be up to 2%. But there's very little support sort of beyond where the M&E consultancy stops. So let's have a look at the mesh consultancy model as an alternative. So we're doing the SAP calcs to get the initial planning sort of underway. The thermal modelling will probably run alongside that and get that optimization so that we can sort of optimize the SAP calculations early on, and the feasibility study is completed. So at that stage, we're up to about half of 1% of the build cost. Then the full M&E specification. Obviously, that builds on what's already been done here. So whilst that bar looks shorter, it's because it's building on from what's already happened. It's doing its job. And then finally, the installer referral. So again, that traditional M&E consultant might well have just sort of let go of the reins at the point where they've issued their specification, and it's up to you're on your own a little bit. Then the build support, and finally the subsidy application. So you can see we're getting up towards that 2%, mark, and we've gone a little bit beyond where we might have been with a sort of more traditional setup, but we've taken a huge amount of risk out of the system, and we've also optimized the system a lot more because we have studied everything in a lot more detail back at the front end. So we're not trying to squeeze a system into a building that wasn't really designed for it in the first place. These might be in a more traditional sort of design scenario. So let's have a look at that as a sort of graph. So here's our traditional design scenario. So you can see at concept design, there's relatively little input from a traditional client. They're just doing the SAP calculations. And there's a huge input at stage 4 as the detailed design is done, and everything's sort of poured in at detailed design stage. And then again, there's relatively little at the back end. Let's contrast this with the mesh model. So you can see it's a much more even kind of spread throughout the project. So I would always sort of think of this as if you integrated the area, so they found the area underneath these curves. So I think that's where the value is, and I think if you add up the value underneath this green curve, you'll find it's quite a lot larger than the red. Although obviously there's this peak in the middle here where there's a huge amount of design effort going in, and jobs are probably moving through those sort of traditional consultancies quite quickly. It's not really where Mesh is doing. Okay. So I said this can sound a bit salesy, this presentation. I do apologise for that. So let's have a little look at the sort of benefits of going through this process. Is we've got the increased customer confidence because the customer's making decisions based on real data all the time. We've got increased confidence the design team because again, the design team know that they are that they're being that everything's being based on analysis and numbers rather than hunches or rules of thumb. We're reducing the design risk because we're lumping a lot more up front, and we're basing decisions on fact much earlier. We've got quite a lean design team because again we're getting so much done and we're working collaboratively so early on that we don't have to have a huge design team for that middle chunk. And we're showing the clients where the smart investment of their money is throughout the project, and we're obviously increasing support. So that's why we think this is the best way of going, and then that hopefully leads to a better chance of total project success, which is what we're all aiming for, which is a great building at the end of it that everybody's happy with. So if there was sort of a few sort of key takeaways, I would say from this this presentation, I'd say start thinking about how you're going to get your sustainability done early, and that is everything from where you put the building on the site and its orientation onwards, because those really key early decisions can make a massive difference to the overall outcome. Start thinking about thermal modelling, building fabric really early on. Construction techniques, everything else, they can really make a huge difference. Modelling those things as early as possible, even if it's a really simple block drawing. We've done projects where people are looking at things and it's literally a scribble on a piece of paper and can you tell us what the benefits of using this construction technique rather than that one might be, or which has got the lowest carbon footprint in terms of embedded carbon, and what's the likely running cost difference going to be? We can do that quite easily. And then as we refine that model, it reduces the risk of costing mistakes, and then it also and then it gives very little added cost over working with a more traditional manner with that sort of big design lump in the middle. I mentioned at the beginning, this is everything that I've sort of talked about today is contained very much in a book called Right First Time. That's available to download for free from our website. There is a link there. It's probably quite hard to read on here, but if you go onto our website, you can find it on there. Okay, so I'm going to now ask Rhiannon, please feel free to type any questions you've got into the chat box. I will so I've got one thing from Les Morrison says as an architect, I don't agree with your curve. So maybe Les can maybe expand on that a little bit and just what is it you don't quite agree with on there? Has anybody else got any questions? Please feel free to type them away.
Also, I'll just add that before, if Les lets us know a bit more about his comment, just to let you all know that a follow-up email will be sent out with the webinar presentation and slides. We would also include a recording of the presentation, and this will be tomorrow. So normally I'll try and get it out by close of play today, but we have let some of our employees have holiday, so this will come out tomorrow, and it will also be followed by your CPD certificates. So just a bit of housekeeping there, just to let you all know.
Oh, I give much more time to site supervision and inspection of detail. Okay, that's an interesting point, Les. I think you're right that inspection of detail. I'm thinking purely from the point of view of where the M&E side might be done, but again, hopefully we reduce that requirement for a lot of site supervision by careful selection of those subcontractors and also nailing down the design up front. So yes, you might need, if you have a less detailed design, then you're probably going to need more site supervision. I mean, obviously these curves are quite generic, so it's not quite as it's not quite a cut and dried as maybe I made it sound, but yeah, I take your point. Any other questions? Okay, so your indemnity insurance wouldn't, it's a subcontractor responsibility. Yeah, I take your point, but obviously again, you know, nobody can be an expert in absolutely everything. So it's worth, yeah, I take your points on that. Any other questions, or have I bored you all in submission?
If you do have any questions at any point, please feel free to drop us an email at info@mesh-energy.com. Obviously, there might be something you think of after the presentation, so we'd be happy to come back to you if that is the case.
Okay. Well, if there's